Hello, this is me, Samuel Ambrose, and I'm loving it because we are doing the practical example to show how the system is developed and how the system works. Now that we have written our program, we are compiling it. So I wanted to show you how compiler work in the previous video, but I just gave you the definition of compiler. Compiler, like it turns the algorithm or the written program in the human language to the machine code or machine language, but it has to go through stages. So let us see all the stages of compiling, and that is what this video is all about. So the first thing is we write our code in the human language. That is the function there we have written in the human language, but that human language we are writing it in Java. We have written it like you can read, because Java is a user friendly. You can read all the syntax in Java and understand. you know Now, after writing that, we need to compile it. So you compile the Java code that you've written using a command called Java Arc, Java compiler, Java C. So this is saying that we have a Java program. We have a program written in Java language. Now we need to compile it. So compiling is about turning this program we have written in Java into bits, but it has to go through some process. So once that has been compiled, because compiler will take this program written in the source code. This is our source code. The source code is written in the human language, but in the Java language. It's written in the human, I would say English language, but in Java perspective. We are using Java technology. So when we compile, we we change all this into what is called a bytecode, which is a string of numerical values and constants. These numerical values and constants create what is called a virtual machine as well for the Java. You see? So we now have to convert this one into the bit code. So remember, we have source code, which is the system that we have written, compile into the bytecode, which is a string of numbers and values. And then this bytecode contains a virtual machine which interpret this bytecode into the bits that machine can run. This one now will be run in the processor of the computer system. And this can run now in any other operating system because you have already compiled. You got the bytecode, which is the class file. If, for example, the file name was Java, let's say sam.java. Here we compile it, it will be sam.java.class. I think it will be sam.class because it has to have a class file. The file extension is class. This one is Java. This is class. And then from there, the virtual machine will handle the work to turn the code, the byte code, into the bit code. Remember the bit code now, everything will be 01010. But from here, things are in a massive string of numbers, but not readable by human. But the virtual machine can be able to read it, interpret it, change it to be compatible with any operating system. And then once you put in any system, it will be changed from here to bits, and then it will run in the hardware as the binary instruction. So all this function that we have written there will run as the binary instruction to interact with the hardware. From here, that binary instruction is actually where now things are in bits, in electrical pulse. There's a flip-flop circuit inside the circuit board that will now take this instruction, group them according to how you program it, and then the magic now occurs inside the processor there. So my friend, that is going to be our next video. We are going to see the step-by-step process of how this thing is processed inside the processor in order to get our output, which is yellow. So I hope this video has been informative, and I hope you will like it when we get to the next stage. So what to take home from here is the kind of codes we have uh, when you're compiling the source code. So once you've written a program, let's say in Java or any other programming language, I know some other programming languages may not need to be compiled. They have like auto compilation, for example, the web programming languages. But with object-oriented programming languages like C, C++, Python, and things like that, Python, you don't even need to compile Python, but the system compiles it. You just run it. That's why Python is also portable. But with Java, Java is a heavy-duty object-oriented programming language, and I recommend that you learn Java, because once you know Java, any other programming languages will be very simple and easy for you, not only to learn, but to use it as well. So, what to take home from here is the source code, which is the program we have written. Those comprises of those function, yeah, with a class file, obviously. And then when you compile it, it will create a bytecode. Bytecode contains numerical values and constants from our code or from our source code, but is not readable by human. And that contains the virtual machine in Java, Java virtual machine. And this virtual machine is like an interpreter. It's like a converter. It interprets this one and changes it into the bit code. You see, bit code is the machine code. The machine codes is full of binary instruction or hexadecimal instruction.